In every corner of the world, remote wild places are thriving with rare and magical forms of life. Or are they? Statistics prove that life in the wild is disappearing, and quickly. 137 species become extinct every day. 50,000 vanish forever each year. But extinction may not be inevitable. In fact, the new technology of assisted reproduction could force the threat of extinction itself to disappear. Today, zoos around the world are full of endangered species. In the past, they were all that kept many animals from disappearing completely. But in the future, they'll be protected in a completely different place. It's called the frozen zoo. Here, the living cells of an incredible array of wild animals are being preserved for scientists to conceive, even clone endangered species.
This is the way I think we're going to transport animals someday. Someday I see us with liquid nitrogen tanks on airplanes, literally hauling a herd of animals across the world.
Stored in liquid nitrogen at minus 196 degrees centigrade, tissue samples, sperm, eggs, and embryos from hundreds of animals can be kept for literally thousands of years. They may look small, but each of these containers can hold a herd of water buffalo. It's a frozen Noah's Ark.
We're now freezing not only reproductive cells, but we're freezing skin cells as we do work with cloning. And in my mind, the frozen zoo is one of the most powerful tools in assisted reproduction technology.
It may sound like science fiction, but for some animals, it's their last real chance for survival. Yet whatever reproductive technique is used, the real trick is to find each one of them a mother. Scientists are now learning which animals make good surrogate mothers for their similar but endangered cousin. Like qualifying an organ transplant donor, the surrogate must be compatible. And for animals like the lowland gorilla, time is running out. Of all assisted reproduction technologies, cloning is the cutting edge. And scientists here are working hard to improve their techniques.
The cells. These are the bongo cells, and they're from Mariah, who's our most endangered bongo, really.
We'll get started on that. We used a technique which is called interspecies cloning. And what that involves is actually taking the egg from one species and the cell from another species and combining the two to produce an embryo.
Dr. Damiani was part of the team that carried out the first successful cloning of an endangered mammal, a cow-like animal from India called the guar. Now he's trying to clone the almost extinct red-striped African bongo, using another antelope species as its surrogate mother. An attempt to clone a bongo is about to begin. DNA from bongo skin cells is being implanted into the egg of an eland antelope. In this lab, researchers must work under red lights. Daylight could cause a chemical reaction that might damage the cells and ruin the procedure.
What we're doing with the cloning process is we're making an identical copy of the animal that donated the cell. Instead of actually putting the bongo embryo back into a bongo, we can transfer the embryo into an eland.
Using a needle finer than a human hair, the bongo cell sample is inserted into the egg of the more common antelope.
And right there is the bongo cell into the eland oocyte.
A jolt of electricity is sent through the ovocyte, fusing the egg and cell into an embryo. Within a day, the cells are replicating, and it appears that a new bongo is on its way. But more likely, it will take hundreds of attempts like this one before an animal is actually born.
Ideally, we would like to transfer the bongo embryos into a bongo and then have that bongo give birth and so forth. The problem is there's so few bongos for us to work on, and rather than having that whole species go extinct, if I can put it into a common eland with the chance that a bongo calf is born healthy and then reintroduce it back to the bongo population, you know, it's kind of a last-ditch effort to save these species.
Like the African bongo or Indian guar, the world's great cats are also in danger of disappearing. So far, it's proven impossible to clone a cat. But as they perfect their techniques, scientists are identifying which cats make good surrogates. A few years ago, an endangered African wildcat kitten was born here, and its mother was a domestic house cat. Now scientists are working with other endangered cats, fertilizing their eggs in test tubes and implanting the embryos into surrogate mothers.
We're trying some of this work between lions and tigers. Now, nobody's ever done this before between lions and tigers, but since lions breed somewhat quickly in captivity, and we have large numbers of them, whereas tigers, there's some very endangered subspecies of tigers. If we could use the lioness as a surrogate for tiger embryos, then that's another step that we're trying to take.
In the human world, cloning experiments, test tube babies, even surrogate motherhood has been controversial, even scandalous. But assisted reproduction technology could save nature's most endangered animals, who for the most part were driven to extinction in the first place by humans. And if the Earth's wild places are to remain truly wild, it's now a problem only humans can solve.
Saving wildlife is going to boil down to not just one answer. Here at the Audubon Nature Institute, we have chosen to do what we do best, and that is preserve the genetic material from these animals. That's not going to save all species, but neither is saving habitat. Neither are zoos that maintain living collections of animals. It's going to take all of these solutions, I think, to indeed really save wildlife. So it's up to us, I think, with the tools and the technologies and the knowledge to be able to help save these species in any way that we can.
But once an endangered species has been saved, what next? Today, WildTech is helping the endangered whooping crane return home by teaching them a long-forgotten migration route. A few years ago, Operation Migration became famous for using ultralight aircraft to help lost birds find their way home. Their story of working with Canada geese even inspired a successful Hollywood movie. But what they did in the past was only a dress rehearsal for what they're doing now. Operation Migration's pilots are now flying with whooping cranes, teaching them a new migration route down through eastern North America to Florida. The whooping crane is North America's tallest bird, but its size became a liability, and by 1941 there were only 15 left in the world due to hunting and habitat loss. Today, despite international efforts to save them, whooping cranes are still on the edge of extinction, and most survive in captivity. In the past, biologists had a problem. They could breed and hatch new whooping cranes, even preserve their wildness by using puppets as surrogate parents. But they couldn't teach them how to migrate, a key survival strategy. New ultralight aircraft technology provided the answer.
Technology is critical to the survival of this species. If you didn't have the captive breeding centers, I don't think the population would have survived. We have the GPS navigation, we have the satellite tracking system. It couldn't be done, without that technology. And of course, the aircraft itself is, although it is an ultralight and people think of them as kind of flying lawn chairs, that they're really are state-of-the-art aircraft.
Easy to control and inexpensive to fly, ultralights are a new age solution to an age-old problem. They soar through the air like a windsurfer riding air currents and can land or take off almost anywhere, something no other aircraft can do. Whooping crane chicks recognize the first thing that nurtures them as a parent. It's called imprinting. To make sure that they imprint on cranes rather than humans, the biologists and ultralight pilots wear unique costumes and use hand puppets to fool the chicks. Ultralight aircraft were chosen specifically to teach the whooping cranes how and where to migrate. They fly the same speed as the birds. And the open cockpit lets the pilots and birds keep a close eye on each other. But most important, the cranes have established a relationship with the ultralight itself.
We always say that birds are imprinted on the handlers and conditioned to follow the aircraft.
Now in the second year of Operation Whooping Crane, the pilots are planning to lead 17 juveniles south to Florida. Today, there's only one flock of migrating whooping cranes flying from Alberta to Texas. At any moment, a single storm could wipe them out. The reintroduction of this second, eastern flock is key to the crane's survival. And based on the success of year one, everyone here is optimistic.
Our first year with whooping cranes, it was a migration was 1,250 miles. When the birds returned on their own, they came right to the field with a vanish. They landed right on the field where they were raised. There's some homing instinct that brings them back there, and we don't really know the mechanics of that yet.
While they're in costume, the reintroduction team doesn't speak a word. They need to keep the whooping cranes as wild as possible, and never seeing a human face or hearing a human voice does help. So far, biologists have found that the returning whooping cranes are remaining wild and elusive. Finding the cranes within the wildlife sanctuary is a challenge for researchers who want to monitor their movements and behavior.
5 of the released whooping cranes from last year came back to this refuge, and all of the birds are, since they've come back, have started to do what we think are good behaviors for cranes. They're roosting in water, they're finding enough to eat, they're relatively wary of humans and vehicles, and so that's very encouraging in terms of, you know, whether or not they're going to start reproducing.
Whooping cranes in the sky is a sight not seen in northeastern North America for almost 100 years. For the pilots, preparing for the migration flight is intense. To stay finely tuned and ready to fly, the ultralights require constant maintenance of their GPS navigation systems and radio communications.
I guess we've perfected the methodology in leading birds. Over the years, we've faced a million problems and found a million solutions. And the design of the aircraft has been slowly modified over the years. We've gone from calling the Canada geese with our "come on geese" calls to calling the cranes using actual digital recordings of the birds. We've developed better bird guards to help protect the birds from injury with the aircraft. We've developed quieter propellers. That's all evolved over the years.
It's taken months to train the whooping cranes to fly behind the ultralights, while the migration itself, from Wisconsin to Florida, lasts about 50 days. It's a difficult journey, but in the end, the effort is worth it.
You get a feeling of almost feeling the bird on the wingtips. You know, you can feel when it's out there flapping its wings. The vibration comes through to your arms. You can feel it. You can see it. The senses are kind of awakened, you know, and so you're a little bit more alive to what's going on around you.
Whooping cranes are still one of the most critically endangered bird species in the world, and the secrets of migration remain a scientific mystery. But for now, the innovative use of ultralight aircraft technology is helping to bring whooping cranes home to the wild skies of North America.
You look out and you see these birds that have been around for 9 million years, have come so close to extinction, yet they're here. This is a bird that came as close to extinction as you can get and still survive. And we have an opportunity to save it.
Throughout human history, the bat has been a creature of myth and mystery. Hunting only at night and sleeping in caves during the day, their clandestine world is the stuff of Gothic novels, comic book heroes, and not much else. In fact, almost nothing is known about the real life of bats. But now, new thermal imaging technology is allowing scientists to study bats for the first time in their own wild world. Thermal imaging registers heat, and it's revealing secrets the human eye is incapable of seeing on its own.
All of a sudden, all sorts of things are possible that weren't possible before. What I've seen of the thermal imaging is that it's going to allow us to answer questions that we couldn't even dream of answering before.
Despite their small size, some species of bats can live an incredibly long time. Why has always been a mystery. But some suspect the secret of longevity is hidden in its body temperature. Bat sex is another mystery. They seem to live in a world of free love, where each bat mates with any other that's available. Genetic evidence suggests there's an order to this orgy, but no one knows for sure. Thermal imaging may solve these mysteries by recording bat behavior in total darkness.
All objects above the temperature of absolute zero naturally emit heat, and these cameras sense that heat. The active bats are showing up as white, meaning they're showing up hotter than the walls of the cave. And the really active bats, the ones that are flying around, are showing up even warmer than the ones that are lighted on the wall.
Now that it's possible and practical to study bats in their natural habitat, thermal imaging cameras are being used to understand why body temperature is key to their incredible lifespan.
The little brown bats that are so common at this location, it's an 8-gram animal. 8 grams, and yet the age record for these animals is over 30 years at, sort of life in the wild. So they must have something going for them.
In human years, the average age of these tiny brown bats exceeds 5 centuries. Scientists knew these bats were longevity champions, but they didn't know why. Thermal imaging has revealed that when bats hibernate, they don't just sleep, they almost die.
Bats generate body heat. Even when they're hibernating, they generate a very small amount of heat that can be detected by the cameras. What was astounding was just how cold their bodies can get, and thermal imaging provided the answers to that.
Well, one of the mysteries about bats, in a way, is how bats deal with winter. You can go into hibernation sites in the winter, and it was astonishing to discover last winter with a thermal camera that the bats were actually colder than the stone of the mine or cave in which they were roosting, and we didn't really expect that.
Thermal imaging shows just how cold the bat's hibernating sleep really is. Perhaps it's a lesson for humans who want to live a long time. Simply lie down on a bed of ice and wake up in 100 years. But as thermal imaging has also revealed, the secret is, after waking up, you have to warm up.
As they warm up, we see the brown fat tissue acting like a little thermal engine, heating their whole bodies up. And gradually their bodies come up to temperature, and then they fly away. Unlike bats, humans are incapable of seeing in total darkness. And until recently, scientists relied on elaborate photography systems to capture images of bats in the dark. When they crossed an infrared beam, a flash was triggered, and a split second in time recorded.
The pitch black, all of a sudden, bang, the flashes go, and you see all the detail of the bat frozen in space. And I have yet to meet anyone who doesn't find that quite mind-expanding.
But older technologies offer only a glimpse of the bat's real world. Thermal imaging is capable of revealing intimate, real-time details like how do bats choose a mate? Until now, no one had a clue.
When you watch bats mating, there's no rhyme or reason. A female mates with several males, males mate with several females. It's a mating system that appears to be random and promiscuous. And yet, the young are more closely related than their mothers. Well, that suggests that a few males are fathering many of the young. So there is some mechanism for choice. My theory, which is just good old armchair biology, is in fact that perhaps they're picking hot males. And perhaps, you know, if you're really hot, you're much more attractive. You perhaps are viewed by the female as being better. We'll see. With the thermal imaging camera, we can perhaps actually find out.
Once hidden deep inside the Earth, observing the secrets of this mysterious creature now has nothing to do with shining new light into primordial darkness. Thermal imaging has exposed the natural world of the bat by taking pictures in shades of hot and cold. In the future, this wild technology will answer many more questions about longevity, hibernation, and perhaps even our own desire for immortality. The rugged west coast of North America is home to the majestic bald eagle, one of nature's greatest wild icons. Out here, they're the kings of the sky, but some people, it seems, still like to shoot them.
When I first saw the eagle and saw how his beak was blown off like that, I felt that maybe the most humane thing would be to have it euthanized. It looked that bad.
Robin Campbell's seen a lot of inhumanity in his time, but he refused to quit on this bird, although he knew he had a big problem on his hands.
Did they get fungus or like?
Here he is here, Dr. Andrews. I don't know what you think.
An eagle's beak is made up of the same protein as human hair. In normal conditions, it grows continuously, and in most cases will heal itself. But the bullet had completely destroyed this eagle's ability to regenerate its beak. So what did Robin Campbell do? He called his dentist.
I'd phoned a number of dentists and denturists, and none of them could help me. But I put an ad in the paper, and I actually had 15 different clinics call, one as far away as Alberta. And we chose Dr. Andrews. We thought that he was the best to work on this bird. We see a little...
No one had ever built a new working beak for an eagle. But if Dr. Andrews didn't try, and quickly, the eagle would die.
That's really good.
The challenge was to construct a beak strong enough to let it eat, but still allow it to breathe.
Any problems? You don't see really any growth?
When he went to feed, this part of the beak, when he bites hard, it bends the beak back into his skull here and puts exquisite pressure on there and probably gives him a considerable amount of pain.
Dr. Andrews, too, had seen a lot in his time, but an eagle in the dentist's chair? He soon found out, however, that working on the bird was only as difficult as working on a human patient with a really big nose.
This is a plaster cast, very similar to what I would make if I was making a denture for a person. These materials and techniques are precisely what we use with doing day-to-day dentistry. It's just that we've had to apply them to a different type of project.
Soon enough, they got it right, creating a beak of light acrylic and breathable chrome.
I'm not left-handed, but...
As if he knew what they were doing, the eagle remained calm throughout the procedure.
When we cast this and polished it, Fred Leake, the technician, he made sure that is just razor sharp along here. So when he incises things, he cuts them off extremely readily.
All done on volunteer time, this original collaboration not only built an innovative beak and saved an eagle's life, it created world experts in the new field of wildlife dentistry. The beak even inspired a name for the eagle.
Someone came to me and they said, well, what's the name of him? So I just said, well, his name's Brian. He kind of thought it was funny that I would name him that, but I can't think of a better man than Dr. Andrews to name it after.
Brian the bald eagle will never return to the wild, yet he'll always be an icon, part of the new way technology is affecting the natural world. But as it turns out, Brian's not unique. On the opposite side of the Rocky Mountains, wildlife dentists are also working hard to save elephants. Calgary, Alberta is about as far from home as an Asian elephant can get, and it was here that another wild tech breakthrough occurred. West of the Mississippi River, the largest land mammal in North America is an Asian elephant called Spike. Weighing in at about 12,000 pounds, he was happy living at the Calgary Zoo, often getting pedicures from his keepers. Happy, that is, until he broke one of his massive ivory tusks.
Well, originally Spike broke his tusk by playing with his toys, and what eventually happened is just that this whole part of this tusk broke. And what we tried to do was cut this off at one point here. You can see where we tried to cut it off and then found out that it was cracking even more. And we finally had to take it off right at this point here.
An elephant's tusk is just a big tooth. If the crack in Spike's tusk continued to extend back into his skull, he'd feel excruciating and perhaps life-threatening pain.
So there was some urgency to find a way to repair this, or at least to try and minimize the amount of damage that he could do to this tusk again.
The zookeepers decided that the best way to control the crack was to put caps on Spike's tusks. But they needed something bigger and with a more precise fit than the circus-style caps that were available. They needed Spike-sized tusk caps, but they didn't know how to build them. A local technical college was their first stop for advice. Teachers and students volunteered to build the first ever custom-designed tusk caps. Normally, they learn to design and build heavy industrial machinery. So making an elephant tusk cap was an exciting new challenge.
The biggest problem for us, the technology side of it, was that it wasn't round. It had a taper on it and a curve in it. So we were really at a loss as to how to get the actual shape of the part that we wanted to build.
Unique design problems demand a trial and error process, and before deciding on which material to use, the technicians needed precise measurements of the elephant's tusks. An early model didn't fare too well when the keepers tried to put it on.
They had tried to fit this wooden prototype onto the elephant, and Spike didn't think much of that. And the elephant sort of wrapped its trunk around a piece of wood and pulled it off itself. Put it onto the ground and stomped on it, and then picked it up, put it in its mouth and chewed it and cracked it, and we could hear this cracking sound. And there was all our prototype being eaten by the elephant.
Using computer models, they soon got the tusk design right. And to be strong enough to withstand Spike, they decided to build them out of stainless steel.
We wouldn't have been able to manufacture this cap unless we had some sort of computerized machine tool to do it. And it programs a tool path, and the cutter moves automatically through the whole process.
Those tusk caps are going to be on there pretty much for life. It's always the long-term answer that we're really worried about. I mean, tusks, or Spike's still going to play with his tires, and he's still going to put a lot of force on his tusks, and I mean, that's going to be the real test, is whether they can surpass the 12,000-pound elephant test here in the long run.
Today, Spike's been saved from the world's worst toothache. Now he's not only the largest elephant around, he's also the brightest. And with the only stainless steel tusks in town, he's more popular with the ladies than ever before. At just 20 years old, Spike has a long and shining life ahead of him. Known as the chain of life, DNA is helping track criminals in the human world. In the wild world, it's tracking animals in amazing new ways. Nature's detectives are next. In the past, scientists used radio signals to track wildlife and needed to trap or tranquilize their subjects to attach a transmitter. But today, the same DNA technology that police around the world use to chase criminals has become a new hands-off way to track animals. In a unique case study, scientists in a lab northeast of Toronto are following the endangered swift fox half a continent away on the Great Western Plains.
Using the same bits of DNA that are used in human forensic analyses in murder and rape cases, but we can now analyze them in swift foxes and get information about parentage, offspring relationships, and other kinds of relationships. You'd have to do a lot of trapping and radio collaring to come up with the same kind of equivalent data.
The swift fox is the smallest of its kind in North America. 100 years ago, there were thousands of them, but its prairie home was transformed by farming, and the swift fox began to disappear. By the 1970s, it became extinct in Canada, and remains endangered in the United States. Today, the swift fox is being reintroduced to the prairies, and its future in the wild is being tracked using its DNA. Swift foxes could still disappear at any time, and so a non-intrusive tracking method is critical to their fragile survival. DNA analysis seems perfect. In the lab, geneticists extract DNA from hair samples. Each swift fox has a unique DNA profile, just like a fingerprint. But this profile not only identifies the individual fox, it can connect it to its entire family tree. In the future, this means that all scientists will need to do to monitor any wild animal species is to analyze its DNA profile. In it, they'll see clearly if an animal like the swift fox is breeding or disappearing.
The one thing that an animal never loses is its DNA profile. DNA really is the first information technology. Computer software people pride themselves on their IT, but really DNA is 1 to 2 billion years old. It does carry the information of life. And when we can get a sample of it, we have a record of who it was, or it may now look like an offspring of one of those animals that were released. So we're getting information from animals without ever seeing them.
2,000 kilometers away, biologists are getting swift foxes bred in captivity ready for their reintroduction onto the prairies. Hair samples are collected from each fox before they're released.
I mean, DNA is a very useful tool for us because it allows us to monitor the swift fox population in the wild in a non-invasive and humane manner.
So far, over 800 of these tiny foxes have been released, but many have died. It's an ominous sign that reintroduction may not be a success. As these biologists work hard to save the swift fox, DNA tracking is now crucial to its survival. In fact, DNA may be the only way to monitor the health of the entire population. No other method can accurately tell if the foxes are breeding successfully in the wild.
The monitoring is important. You need to know that these things are breeding. You need to know there's connection between the populations. While they're in captivity, they're not really a swift fox. We're keeping them, but the end point is clearly to allow them to fulfill their role within their ecosystem.
This year, the swift fox is being released onto the Blackfeet Reservation in Montana. It's only a small piece of their vast evolutionary birthplace, but it's the best chance they'll have to thrive and multiply. Full of grasshoppers and ground squirrels to feed on, the great open plains themselves are the fox's best natural defense. This is big sky country, allowing them to see a predator coming for miles. They're left in their cages to readjust to the sounds and smells of their long-forgotten homeland. Soon enough, they'll be released. And when they are, they run quickly into the tall prairie grass. Well, some do anyway. It's a bit scary out there. These researchers are nervous too. High mortality rates means there's no guarantee these foxes will survive. But DNA technology will help them track either success or failure.
Without the DNA technology, it would be quite difficult for us to monitor the population as a whole. And it enables us to identify individuals, and we know then which individuals that we've released here have bred in the wild.
It was one of the success stories to this point in that the reintroduction effort has worked, and there are larger numbers. They're clearly reproducing in the wild. DNA is millions and billions of years old. And it's that thread from the origin of life. We need to conserve that.
No one knows if the swift fox will survive in the wild. We do know that New Age DNA tracking will let us know, and hopefully later. rather than sooner. Another important part of the wild tech revolution are satellites, tracking the state of the entire planet. Around the world, nearly 2 million different species are known to science. But as many as 100 million more are still out there, most of them alive and well in the microscopic world some call inner space. In the past, microscopic life could only be studied after it was killed and preserved on a glass slide. Now, an exciting technological breakthrough has created microscopes capable of viewing this world alive and in Technicolor.
For the first time, we can go inside a cell and see what's really going on inside a living thing without having to kill it.
It's a whole new view of life. These real-time microscopes can even record and store images outdoors, something previously impossible. Back in the lab, even more powerful models can actually see inside a cell with unprecedented detail. Inner space is now in plain sight.
It's always amazed me just how much life there is in a tiny little drop of pond water. All of a sudden you'll see a creature that you've never seen before, and you go and look it up in a book and realize that nobody's ever seen it before.
There could be 1 million species in a single cup of pond water, with new species discovered every time someone takes a look through one of these microscopes. Originally designed to view cancer cells in real time, they now show for the first time that all life really is interrelated.
So it's like you've gone full circle. You've gone from the very small all the way down into its internal core, and all of a sudden it looks like you're back out in space.
It's hard to believe that one of life's new frontiers can be found in a drop of water, but new visual technologies are revealing a world we've never seen before. The view from outer space is just as astonishing. And out here, another technological breakthrough is helping to solve a major environmental mystery.
For the first few days, when you look out the window of the space shuttle down at the Earth, you're just absolutely awed by the beauty of this beautiful blue planet down below.
Astronauts in space get a rare view of our planet, but satellites get an even closer look. Some of them, like remote sensing satellites, can take pictures of the Earth's surface from as high as 800 kilometers.
We're using remote sensing to see how changes in the climate and human activity affect our environment and the survival of wildlife species.
But now a Canadian remote sensing satellite has taken on a new role to stop an environmental disaster. Ocean tankers are dumping waste oil in Canada's Atlantic waters, just to save the few $1,000s it costs to have it pumped out in harbor.
Probably something like 300,000 birds are being killed every year out there from this chronic oil dumping. Every year off eastern Canada we have the equivalent of an Exxon Valdez, but it's happening over the horizon, and for most people it's out of sight and out of mind.
The Canadian Coast Guard sends planes out on routine patrols to catch the dumpers, but most captains pump out their bilge oil under cover of fog or at night. Until recently, it was only luck if an oil-spilling tanker was ever spotted. The search for oil-dumping tankers now begins thousands of kilometers away, where data from different satellites is received for processing into pictures. There are many different types of satellites orbiting the Earth, and each provides a different view. Some, like the Iconos satellite, provide unprecedented close-up images. Others, like NASA's Landsat satellite, monitor long-term changes in ecosystems. Most, like the NOAA weather satellite, are limited by the Earth's atmosphere. They get spectacular views of events like hurricanes, but none of them can see through clouds to what's happening on the surface of the water. But Canada's RadarSat satellite is different. It can see through a hurricane. In black and white images, the RadarSat satellite captures wind patterns a hurricane makes on the ocean's surface. Its ability to see through clouds, fog, even darkness, has produced a one-of-a-kind map of Canada and the first complete, cloudless map of Antarctica. It can also record images of oil slicks on the ocean's surface. A thick oil slick appears calmer than the water around it and shows up as a dark black streak on a satellite image.
RadarSat is set up in such a way that it can respond very quickly when you get an oil spill. Doesn't matter really much what else you thought you were going to do that day.
Now, when the RadarSat satellite detects an oil spill on the water, a Coast Guard plane is sent out within the hour to videotape the crime scene for use as evidence in a court of law.
Yes, good evening, sir. Speed Air 01, Coast Guard surveillance aircraft. We just flew across an oil slick directly astern of your vessel.
Speed Air 01, I have not been cleaning any holes or pumping out any oil. Over.
Roger, sir. Okay, we do have pictures and we do have video showing oil slick, a slick 6 miles in length, directly astern and in the wake of your vessel. Over.
Roger, sir. Well understood, but I'd like to reconfirm that there is absolutely no ballasting, deballasting, or any pumping out going on board my vessel.
Roger, sir. We have that, and just for your information, we will pass on what we have seen to St. John's Coast Guard Radio, who will forward the information on to Transport Canada Marine Safety.
In Newfoundland's cold winter waters, a seabird with even a spot of oil on its feathers can die of hypothermia. And there's only one way to save them: prevent the oil from ever getting into the water. The RadarSat surveillance program seems to be a success. It's helped the Coast Guard catch a tanker dumping oil, and both the captain and the shipping company are now being prosecuted in a Canadian court.
I feel really heartened. For most of my career, we've been seeing a problem getting worse and worse, and we haven't seemed to have the tools to deal with it. There is now hope of our doing a better job of conserving the populations of birds. I think that's really helpful and a hopeful sign.
It's astounding, really. You know, when I was in remote sensing when the Earth was young, you know, I've been there since pretty much before they coined the term remote sensing. Satellite imagery has really improved tremendously.
The wild tech revolution is helping us to understand and hopefully save the natural world. It could bring an end to extinction, and it is helping to return endangered animals to the wild. But even the best that technology can offer can't predict the future of our planet. To answer that question, we're on our own.